Students, welcome again. As we are discussing chapter number 2 physical quantities and measurements, and already we discussed that is density equal to mass per unit volume kilogram per meter cube. So here there are the few numericals, that is on page number 28. This is the example number 3rd. A metal sphere of radius 2.5 cm weighs 540 gram. Find the density of the metal and express your answer in SI units. So what are the given values of mass of the metal sphere? 540 gram, radius r equal to 2.5 centimeter. So volume of the metal sphere, and the volume of the sphere is equal to 4 by 3 pi r cube. So put all these values. So 4 by 3 into 22 by 7 multiply 2.5 raised to power 3. So expand these terms and remove this decimal in this step, and we will solve it, and then we will find out that 11 multiply 5 5 are 25, 25 5 are 125. So multiply these two terms, you will get 1375 by 21 centimeter cube. So this is the volume of the metal sphere, and so therefore density of the metal d equal to m over v. So put these values. M, that is mass 540 gram, and volume as we calculated 1375 by 21, put here instead of v. So reciprocate, then 540 multiply 21 divided by 1375. So multiply these two terms, then we have 11,340 divided by 1375. So divided it, then you will get 8.247. Round off, then you will get 8.25 gram per centimeter. So this is the answer in gram per centimeter, but we have to show this answer in SI system. So SI system means into kilogram per meter cube. So as we know that 1 gram per centimeter equal to 1000 kilogram per meter cube. So density of the metal in SI system 8.25 multiply 1000. So remove this decimal, 825 over 100 multiply 1000, then you will get 8250 kilogram per meter cube. Now next numerical, that example number 4. A hardwood cylinder of radius 2.0 centimeter and length 75 centimeter weighs 800 gram. Calculate the density of the wood in kilogram per meter cube. Now look at that. This hardwood in the form of a cylinder. They are giving the radius, length and mass. So mass of the cylinder equal to 800 gram. Length of the wooden cylinder is L, say L equal to 75 centimeter, and the radius of the wooden cylinder R equal to 2.0 centimeter. And as we know that volume of the wooden cylinder V equal to pi R square L. So put these values instead of R, 2.0 raised to power 2, multiply the value of L, they are given, that is 75 centimeter here. Solve it, multiply all these numerators, then you will get 6600 over 7 gram per centimeter cube. Sorry, not gram per centimeter, this is only in centimeter cube. This is the volume, so please correct on your books also. 6600 over 7 centimeter cube. Now density of the wood T equal to m over v. So put the value of the m, that is mass 800, and the volume 6600 over 7. Reciprocity, then it will be 800 multiplied 7 divided by 6600. Solve it, zeros cancelled out, then 28 over 33 gram per centimeter cube. So again we know that 1 gram per centimeter cube equal to 1000 kilogram per meter cube. So solve it, then you will get 848.5 kilogram per meter cube. So this is the answer in kilogram per meter cube. Now the next example on page number 31, that example number 6. Now look at that very carefully. A stone piece weighs 125 gram. When the stone piece is immersed into water contained in an eureka can, 55 centimeter cube of water is displaced from the can and collected in a measuring cylinder. Find the density of the stone piece. So what the values are given? Mass of the stone piece, that is 125 gram. Volume of the stone piece, that will be equal to the volume of the displaced water, and that is equal to 55 centimeter cube. So as we know that the density of the stone piece will be equal to mass per unit volume. So what we have to do, just put these values and divide it, then you will get 2.27 gram per centimeter cube. And the next one is that a measuring cylinder contains water up to the level 46 milliliter. So हमारे पास जो measuring cylinder है उसमें ऑलरेडी जो वाटर का लेवल है वो दिया हुआ है 46 मिलीलीटर, एंड एज वी नो दैट 1 मिलीलीटर इक्वल टू 1 centimeter cube. So volume given है. The water level rises to 74 milliliter when a rubber stopper is immersed into it. Then after that we immerse the rubber stopper, the water level rises to the 74 milliliter from 46 to 74. If the mass of the rubber stopper is 45 gram, then find the density of the rubber stopper. It's quite simple again. So mass of the rubber stopper given 45 gram. Look at that. And what is the volume of the rubber stopper? We have the two volumes. One volume of the water displaced by the rubber stopper equal to, so what is the volume of the water after immersing the rubber stopper? That is 74 centimeter. That is V2 minus V1, that is a level of the water in the measuring cylinder without stopper, that is equal to 46 milliliter. So minus it, 74 minus 46, then what is the rise in the water, or what is the displaced water? That will be equal to 28 milliliter, and as we know that 1 milliliter equal to 1 centimeter cube. So volume of the rubber stopper equal to 28 centimeter. So simply then density equal to mass per unit volume. So put the value of the mass 45 and the volume V, that is 28. So divide it, then we will get 1.61 gram per centimeter cube. So this is the answer. Now look at the another example, that example number 8. This is a measuring cylinder contains water up to 54 milliliter level. Look at that. So this is the initial volume. When a glass stopper is immersed into it, the water level rises to 76 milliliter. So look at that. As the previously, similarly, glass stopper immersed in the water into it, the water level rises to 76 milliliter. When a small piece of cork of mass 3 gram is tied to the glass stopper and combination is immersed into water taken in a measuring cylinder, the water level rises further to 91 milliliter. So what they did after that, first they immersed the glass stopper, then after that a piece of cork whose mass is 3 gram tied with the glass stopper, then immersed into the water, then again water level increased 91 milliliter. First water level 54 milliliter, with glass stopper 76 milliliter, with cork and glass stopper now this is 91 milliliter. So calculate the volume of the glass stopper as well as that of the cork piece. Also find the density of the cork piece in SI unit. So look at this. Initial volume of the water V1, that is equal to 54 milliliter. Volume of the water and glass stopper V2, that is 76 milliliter. Volume of the water, glass stopper and cork piece. Now look at that. All are combined. 91 milliliter. What is the mass of cork? They are given M equal to 3 grams. So what is the first we will calculate what is the volume of the glass stopper. So V2 minus V1. This volume is with the glass stopper. So 76 minus 54 milliliter, that will be equal to 22 milliliter. And as we know that 1 milliliter equal to 1 centimeter cube. So 22 centimeter cube. So what is the volume of the cork piece? V3 minus V2. Look at that. What is the 91 milliliter? This is the volume of water, glass stopper and cork piece. And now we know that what is the volume of the glass stopper. So 91 minus 76 milliliter, that will be equal to 15 milliliter. Again 15 centimeter. So this is the volume of the glass stopper. This is the volume of the cork piece. Now the density of the cork piece equal to mass of the cork piece divided by volume of the cork piece. So mass of the cork piece is 3 gram and volume of cork piece is 15 centimeter cube. Our answer is 0.2 gram per centimeter cube. Again we know that 1 gram per centimeter cube equal to 1000 kilogram per meter cube. So density of the cork piece D equal to, so 0.2 multiply 1000 kilogram per meter cube, then we will get 200 kilogram per meter cube.